let's start off. It takes in its inputs sequentially, and then we get this hidden state, and then we get an output, and then we use that hidden state for the next thing, next prediction, instance, whatever you want to call it. It can be whatever. Output. Okay, does that make sense? I mean, the picture you can like understand. So, what is a hidden state?
Just like your network, right?
Well, what is a hidden state? Is actually just a vector of numbers, right? So in this case, usually, I think in this lab, they usually use a 100-dimensional hidden state. We talked about this last time. What does that mean? Or maybe 2 weeks ago. What's stored in this vector?
Your weights.
Your weight. So
No,
Along with
these are not the weights.
well,
We
your
get
input
weights to
vector-
get the hidden state.
Your input vector and your weights is stored like in your state. You just kind of keep track
No,
of
no.
those.
So this your hidden state. So your hidden state is a mixture of your input and the previous hidden state. So what is stored in a hidden state though? What is that vector, Jack?
Is it the activations?
It is the activations, yes. You get it from these activations, but what does it mean? What do these numbers mean? There's like all these numbers, 100 numbers.
Is it
Probabilities.
just, like lit up the word in the vocabulary? Like,
Well, so, or let's say we have a 50 state. How many words are in your vocabulary? There could be 100, there could be 150, there could be 26. So what this is it's storing information about the problem. Does that make sense? So it said, it's storing what have I gotten so far, and what does this letter mean? Does that make sense? And then it uses that information to output it. Does that make sense? So this is a common sentence. So the current neural network could learn that if it says TH, it could learn like, it stores that in the hidden state, and that hidden state gets passed each iteration, because this is the same hidden state getting passed along. Then it can learn like, oh, this is probably going to be an E, and that's what's stored in that hidden state. Does that make sense? That's like the important concept. Well, it's one of the important
It's
concepts.
like this sequence of letters, basically. That's like
Yeah, it's a memory basically. So LSTM, long short-term memory, you guys talk about that?
Yeah.
Yeah, so it's like, it's a memory, it's keeping track of like, it's a state as to what has the network seen up to this point, basically. That's what's called the hidden state.
But it's keeping track of that very abstractly, right?
Very abstractly. Like
Okay.
if we were to look in this vector, we would not see anything recognizable. It would just be these random numbers. But the network learns itself what to store for each value.
Right.
Does that make sense? So what we're going to try to do in this lab is we are going to, well, okay, before we get to that. So what we hear is we hear what's called an encoder-decoder architecture. Who's heard that before? Who understands that? No. So what we're doing is what encoding means is it means we're encoding into a hidden state. So we're like translating something we understand or can see or read, and we're putting it into a state that the machine can then understand. Okay? And then we're going to decode that hidden state into something that us humans can understand again. Does that make sense? Encoder-decoder architecture. So there's different ways you can set this up. So what we could do is we could, so like for machine translation, which is a lab coming up, what they do is like they run the network in through like a whole sentence, and then that encodes a hidden, like that hidden state's fully encoded, and then they decode it by just letting it run through. And they don't have inputs anymore, they just let it output. Does that make sense? So kind of interesting.
But that's not what we're doing this time.
That's not what we're doing this time. In this lab, we're going to input our letter, and then we're going to output what we think is the next letter. Does that make sense? So I have a T, I think I want an H. I've had a T and an H, I think I want an E, right?
And are we giving probabilities for different letters, or just the one that has
Yep.
the highest probability?
That's exactly right.
Okay.
Well, so we predict the one with the highest probability, but we have probabilities for every single letter.
Right.
Does it, is there a way to dynamically basically increase like the number of letters, or do you have to, before you start, basically say, here's the alphabet, these are the possible options?
Yeah, so we set our alphabet before, and I think we have like 100 characters, so it's lowercase, like uppercase, numbers, like punctuation, things like that.
But is it possible to dynamically add that, or is that common practice, or not really?
Yeah, you can't, no.
You can't.
No. I mean, you can like jerry rig it, but you shouldn't. And the reason why is, so how does the machine learn to encode this hidden state?
Through training.
Through training. What does it train? Does it change the hidden state? What's being trained?
The weights.
The parameters, right?
Parameters.
And so what we have is we have, to get a hidden state, so we have this hidden state. To get a hidden state, it's a combination of the previous hidden state as well as your input. And so there's parameters that are used to create this hidden state. And that's where the GRU cell comes from, okay? Is to how do we combine these, the previous hidden state and this X to get our next hidden state. So we're updating those parameters. So if you build a network and you're training it, and then you change your input size, then that changes your model and you lose your parameters. Does that make sense? So I guess what you could do is no, you can't do that. You could assign weights. I guess you could do that, but that would be very complex. I'd have to think that through. But does that make sense? How there's weights that are going to be they are going into our hidden state, and then there's also weights that are going out from our hidden state to our output.
So is X like an integer, or is X like a one-hot encoding?
It's a one-hot encoding. In this case, a one-hot encoding indicating which letter or character is the input. Does that make sense?
Yeah.
One hot. Good question. Okay, so here's another, I don't know, common misconception, but thing that some people get tripped up on. So is this set of parameters the same as this set of parameters?
No.
So when we go from one letter to the next, is it the same set of parameters? Yes, it is.
What?
Yeah, so when we
I
use
thought the H's change.
the H changes, but the parameters, the weights, do those stay the same?
Oh, wow, that's tricky.
They do, right?
Yeah.
So our inputs are changing, our hidden state changes, our X changes, but our parameters do change. Or our parameters are the same,
The weights.
the weights.
But we're initially getting all of those weights or those parameters from training it. So it's only once we're like trying to get something from it that they don't change.
Well, so,
Yeah.
yes, kind of, yeah. So what we do is, the training is a whole different nasty story.
Okay.
But, yes.
But
The-
once we're actually using it for validation or like that kind of thing.
Those parameters do not change
Okay.
when we're trying to predict, no. So how training works is, we're gonna set some type of chunk size. Do you have a better marker actually, Peter?
Yeah, I have.
Sorry, this marker's failing as well, it was gonna fail. So chunk size, and I think we like suggest a chunk size of 80. And what that means is, we're gonna have some corpus. You guys know what that means, right?
No.
Corpus, that just means a big text document, okay? That's gonna be what we're gonna use to train on, that's what corpus means. So in this case, we're gonna use the Book of Alma. Okay, so we have this corpus. And what we're gonna do is we're gonna randomly go into the Book of Alma and grab out 80 characters, okay? And then what we're gonna do is we're going to run through that, and we're gonna say, okay, so if it says, and it came to pass, which it always does,
Yeah. That's easy.
and it came to pass. If it says that, I mean, and then we have 80 or however many more characters for our chunk size. So what it's going to do, it's going to go and it's going to run this through the model, and it's going to say, what did I think, what do I guess is going to be the next letter? So we run it through the network, we get a letter, I'll just call it C1, the next character. Okay, then we pass in the next character into the model with the previous hidden state, and then we get the next character, and then we keep going. So what should we use as our original hidden state?
Can you just initialize it to something random?
One.
Yes, random. You should just use random. Are these variables? So let's say we're on our third epic. Is it okay to just switch this to random?
No, you should keep it most previous ones.
Well, so if we're doing random chunks, and this is a new chunk, new epic,
Oh.
should we just what should we use as our hidden state? Is it okay to just set this as random, or would we lose training?
We would lose training.
No, because we're not training our hidden state. We're training our parameters.
If we were to like do the whole book of Alma in order all the time though, then would we want to keep it?
Yeah, but I mean our network, like we're just starting somewhere random. So yeah, we just want to set it randomly because this is like showing like what's been going on previously, and we don't want like there's nothing previous. So it's like we just set it random.
And if you were to pick like a specific letter that you always set it to, it would actually mess everything up because then it would
Exactly.
constantly think that that letter should,
Definitely.
actually give you information.
Right.
So the hidden layer will be random, or
When
the
you start a chunk, right?
okay,
Yeah.
not the parameters. Parameters won't be random.
Yeah, because you want to keep those
keep the
centrally
parameters, but the hidden layer will be random.
when you
Okay.
start a chunk. Yep.
When you start.
And then we run through this chunk, and so we expect an N, right? But let's say we got a G. So is that bad?
It means you need to adjust.
But when we say I got a G, what did we really get? What's C1? Is it a letter or is it a probability of the characters?
Probability.
Probability. So we actually have 100 probabilities, 100 P's. So this seems very conceptual, but like I promise you, if you can like understand this, the lab will be like pretty easy, okay? But it's just you get lost in like what's going on here. Does that make sense?
So Greg, is it training letter by letter,
It
or
is,
is
yeah.
it by 100 by 100?
So we're doing, this is like an epic. So like an epic is
Okay.
like 80, but we are going character.
Correct.
Yeah.
Because some of them, like if you're doing like translation of phrases, you'd compare like 10 to 10 or something, right? Because in the tutorial that's in the lab, it's like sequence to sequence or something, and it's like and it came to pass to the aconteceu or whatever.
Oh yeah.
So is it like?
So
I'm
that's,
just making sure. Is what they're doing in the sequence to sequence translation the same as what we're doing here?
no,
Okay.
that is different. Yeah.
So
This would be more
So
of a
why
batch.
why are we looking at that particular tutorial then, or what value does that one have?
I think that uses recurrent neural networks, but that is different. Yeah.
So the way that it, okay.
Yeah. So we'll talk about that later when you get to machine translation. So I actually have not seen that video, this tutorial. So I'll
It's
have
not
to.
a bit, it's just like a PyTorch tutorial.
Oh, okay, yeah. I'll have to go look at that
So
and
yeah,
make sure that it's
if
actually
you could
helpful.
let us know how relevant that is, that would be helpful.
Definitely. Yeah.
Thanks.
Okay, so we get this G, but it's not actually G. We get vector probabilities, and then we just like how do we calculate loss? Does anyone know what loss we want to use?
Cross entropy.
Cross entropy. Nice. So
Lucky.
what is cross entropy? We take the probability of what? Which class? The false class, the predicted class, the true class.
True class.
True class. So in this case, that would be n, and it'd be like, okay, we wanted an n. What's the probability of that? Take the negative log of that. That gives us our cross entropy. Store that loss. Okay, go to the next letter. Plug in an n. Plug in our previous hidden state, the a hidden state. Get our output. We wanted a d. Take the probability of d. Get a cross entropy loss. So we have two losses now. What should we do with them?
Add them together.
Add them together, yep. And then we can do the add them across a whole chunk. I mean, you can take the
You don't
mean,
have
yeah,
to.
you don't have to.
Well,
And then you pass that loss backwards.
But you only do that after going through your whole chunk.
Yeah, go through the whole chunk, there's 80. You have one loss, right, a scalar, and then you call loss.backward, and then you call optimizer.step. And then that'll pass it back and update your parameters. Does that make sense?
So you don't have to do the mean, or are we just going to use nn.cross entropy, or are we going to do our own?
You can use nn.cross entropy, yes. You just have to pass in a vector, an index of which letter, and then you have to pass in the vector probabilities. Yeah.
So would you recommend using the?
Yeah, I would just use nn.cross entropy loss. But then you do need to sum that across. You can't do that for all 80. You just do nn.cross entropy loss for one character, and then you
So
just sum across.
a for loop then.
Yes. A for loop for each character. As long as you're consistent in how you calculate your loss, technically, an average and sum would be, I think, mathematically the same. But would just sum it. So I'm going to cross this, and then you have one loss for your batch, pass it back, update your parameters. Go get another chunk or batch of characters.
So does the loss need to be a certain type or something? Because based on what we ran into on the last lab,
Yeah, so that's a good question.
The way that it calculates the gradient on the loss thing seems like total black magic to me.
So
But-
yeah, what we have is we have these objects stored in memory, which are PyTorch objects. Who's CS here? Who's not CS here? Okay. So objects are these things in the computer memory, right, that have these properties. So what a PyTorch tensor is, it's an object, and what it does, and this is good for CS people too, but it keeps like back pointers, basically saying where did I come from? Does that make sense? Like, that's when you set up the model. It like keeps a sequence of things, and it says what happened before me, and like what calculations went through me, and how did I get here? So then when you pass loss dot backwards, then the loss came from PyTorch tensors, because you calculate a loss through module classes, right? It passes that backwards, and it says like, oh, here's the different like layers it went through, and here's the different activations, and this is where the loss came from, and why we got the loss that we did, and it stores that in each PyTorch tensor. So we can call loss backwards and there has a class variable for each parameter. It says here's the loss associated with each variable. And then when you call optimizer.step, it goes and it updates those parameters. So what you guys were doing wrong, these two, to use as an example, is they were appending their losses to a list for like a batch, and then they were summing using Python sum, and then what was happening is PyTorch lost where the loss was going, right? Because they weren't PyTorch objects. So you need to
Right,
keep
that
like your
makes-
operations
that
in
makes complete
PyTorch
sense now.
so that it can trace the loss from the loss function back to the parameters that need to be trained.
So loss, the type of object that loss will be is a PyTorch scalar.
Yes, but you need to make sure when you're calculating loss that it's staying in PyTorch objects,
Not like a NumPy
not a NumPy or Python.
Python
Yeah.
something.
Could you show an example of that? Because that makes no sense to me.
Well, so just for example, if we were to store all these losses and append them all to a Python list, and then take the average of it and then cast it to a PyTorch tensor, the loss would be lost because the PyTorch object wouldn't be connected. It wouldn't know what came
But
previously.
if we just stored all their stuff in a list and just use that, or can we not?
No, you can't do that. So what you need to do is you'd have to like create a PyTorch tensor size 80 and then go and put them all in, or keep a running sum of a PyTorch scalar. Does that make sense?
I've never had trouble with that.
You just gotta make sure you're using the plus operator with
Exactly.
because it's got
Yeah.
code written to handle that.
Because it overrides the plus operator. Yeah, that's right. If you don't understand that, that's okay. Just come talk to me if you have problems, I guess.
Bunch of loss items.
That makes sense. It's helpful to realize that there's a distinction between, like, it's because we're using the n and dot modules that it's able to do the back prompts, right?
Yep,
Stuff.
that's exactly right. All right. So any questions on what's happening in the lab? As far as like conceptually, whatever current neural network is, what we're outputting. Oh, I guess one other thing. When we're predicting, what you're going to do is you're going to if you're predicting, you'll give it like a letter, like A, it came to pass. And then what you do is you run it through. You're not calculating loss, but you're getting a new letter. Let's say it says Ed. And then what you do is you pass your last prediction in as your next letter, as your next X. Does that make sense?
You use the like.
And then it just keeps going, and then you get a sentence that the model's just creating.
Where do you get your first letter?
You set that arbitrarily. You can choose whatever.
Okay, so you can
Yeah.
either randomize it or, and how does it know when to stop?
You like tell it. You set that as a parameter. You say go for 30 characters or whatever.
Is that the same thing as your back arching size?
No, it can be whatever when you want. Yeah. So what we're gonna do is we're just gonna run through this code. I mean, it's like we're giving you a lot of code, which is good, but that can also be very bad because if something goes wrong and you don't know what that code's doing, then that can be very painful. So we're gonna go through and we're gonna talk through this code. So I think this will be very helpful actually. This is just the code in the lab specs. So, we're probably gonna go till 6 today, is that okay?
Yeah.
But I think this is helpful, and I think it'll like be well worth your time.
Absolutely.
You can go to
Um,
7, man. Whatever.
What'd you say?
You can go to 7, man. It's whatever.
Okay.
Yeah. 1 hour now is worth 10 hours
Later, it's
So
yeah.
It's like a 7-to-1 trade-off on your time.
Go down, stage all. Whatever. You guys see that code okay?
Yeah.
Ish.
There we go.
There we go.
Yeah. Where's the popcorn?
All right, so what are we doing here? We're getting from the string class all printable. This is a list of all printable strings. So this is something you'd see in these are characters you would use day-to-day basis. So there's 100 of them, uppercase, lowercase, numbers, punctuation. So it's a list, and characters, variable, how many are there? So then we're getting our corpus. This example one is using Lord of the Rings, but you'll use Alma for one corpus, and then you use a choice of your own for another one. How many characters are in your corpus? Yeah, that's it. Okay, we set our chunk length. Oh, I guess in this case we set 200. I thought it was 80, but 200. So we give you this random chunk function. What that does is it goes into your file. They're using global variables, and it just grabs 100 or 200 random characters sequentially, right? So we got to make sure that they're sequential, because it'd be meaningless if they weren't.
So that's instead the 80 that you.
Yeah, that's exactly right.
Okay.
Okay, char tensor. Okay, so this means if we have a string, we want to convert it into PyTorch tensor. So for example, if we had a string of 10 characters, this is going to give us a torch tensor of length 10. And then what's going to do, it's going to go and fill in, let's make sure we get this right, it's going to go fill in that tensor with the values or the number associated with that character, right?
So is that one hot encoding it, or is that giving it an integer index?
That's giving it an integer
So
index.
it's not one hot encoded at this
No.
time, which we'll need to do before
Yes.
we.
That's what it's doing, right?
What's the difference between a variable and a tensor? Like you're wrapping a tensor inside a variable?
Well, so this is a string. Instead, we're turning it into a list of like indexes. Does that make sense? So it's like what's A in ASCII? Like, does anyone know?
7 or something.
7, yeah. So like it's just giving it like these integer values. And
So,
But, he's asking about like the second to last line in that box,
and the return statement?
where you're returning a variable with the tensor inside.
Oh,
it.
yeah,
Like you're
what's
casting
the
a tensor to be
variable?
variable.
What's the variable thing?
To be honest, I'm not sure.
Is that just something that like PyTorch maybe needs it to be a certain type?
From autograd import variable.
What is a PyTorch variable?
So it's something for AutoGrad.
To perform back propagation.
Okay.
I don't know why he wrapped it in that.
Doesn't a tensor already do backprop?
Yeah, it should. Because if you pass in the parameters correctly, then yeah. But either way, this should work. So we can run that. We'll run that in a second. We'll look at it. Okay. Define random training set. What is that doing?
It's just grabbing like a random chunk of your data essentially.
But what is the difference between imp and target? Because it looks like they're both.
So that is input and target. Yeah. So let's talk about that.
So one's going from the back
So we get this chunk. So what does -1 mean?
from the end.
The last character.
We don't want the last character.
Oh.
And then what does 1 mean? 1.
Started
The first character.
We don't want the
First
0th character.
0th character.
So why would we, for input, why would we not want the last one? Because our input, so a character's input corresponds to the output of the next character. Does that make sense?
Yes.
So we don't have the next character because this is the last character, right? The last character, that's the input for the next character, which we don't have in our chunk. So we don't want that one. Why do we not want this guy? Because we don't have the input for the 0th character, because that was the previous character. So that's why.
So in this case, instead of randomly initializing, it's just starting with.
Well, we're just getting
the
our
next one.
vector of integers. Does that make sense?
Okay.
Because we are using char tensor, so we're just grabbing out our x vector and our y vector, basically. That's what we're doing, and we're making it in the format we need.
Okay, so it's basically like
This is our
overlapped
X.
by one.
Yeah,
Yeah,
it's off by
okay.
1. Yeah, that's
I
exactly right.
gotcha.
Yeah.
So
Okay.
we're only learning, even though we're using chunks of 200, we're only learning one character at a time from that chunk of 200.
Yeah, so your x is only the one character previous. Does that mean that it ignores the previous characters? No, it just stores them in the hidden state,
Okay.
right? But a direct input is only the previous character. All right, this is our training loop, 2,000 epics. What does that even mean? I think that just means a chunk. So I think that's really a batch, but print every 100. So that means print your loss every 100. Training loop, get your decoder. That's just our model, right? Where we're gonna pass in stuff and get something out that we can understand. Decoder optimizer, you understand what that is. Criterion, that's just our objective function. We can time it, append our losses. You guys are pretty good there. Okay. So now this is where you have to like writing code is in here. Okay, so we have our model class, recurrent neural network, which we're going to come back to. This is what we'll say for last, okay? But we should input, we're going to input a one-hot vector, and we're going to get an output of what?
Probabilities.
Probabilities, how many?
Same size.
Same size as our input, which would be 100. Okay, we'll come back to that.
Where was that at?
Well, that's just like input size,
Oh.
output size. Those should be 100, right?
Okay.
Those should both be 100. This can be 100, it can be whatever. That's arbitrary hidden size. But this should match how many, like the characters we're reading, which is 100. All right, train. So this is weird because we use a train function. So we're gonna call this train function. We're gonna pass in a training set, which I guess is fine. You just decided to do this. So what we're going to do is we pass in our x and our y vectors, and then what we're going to do is we're going to run through that chunk. This is that for loop we were talking about, and we're going to get our output and hidden layer, and then we're going to pass that into our loss function. We're not going to pass that into our loss function. So what he's like saying here is, we're going to get our output and hidden function from our model. We're going to, because our model is going to take in an output and hidden function, or our x and y. Our model is going to take an integer input, and it's going to take in the hidden state, and then we're going to return the next hidden state as well as the output, which will be the input for the next iteration, right? Does that make sense?
So imp will be an integer.
Well, imp is a vector of integers, but for each for loop, we're just going to go through like one at a time. And then we append to our loss. Like we talked about, we're going to calculate our loss. This will be our cross entropy loss.
So is when we initialize hidden layers, is that just like random
So-
uniform?
Right, so is this initializing parameters? Or is it initializing the hidden state?
Hidden state.
The hidden state. So that's like, that's just going to be, yeah, random uniform. I'm trying to, I'll look back at what other T's did and what I did, but I think it can be between like -1 and 1. Because we don't want to initialize our parameters here because we're calling this once per epic, right? Train. So we're not going to lose our, we don't want to lose our training. So we're just implementing or initializing our hidden state. Return the loss for that chunk or epic. And then yeah, so that's what train's doing. Any questions on that?
And why do we do loss.item?
Because
Rather than just
when you're
loss.
storing loss, remember how I talked about how each PyTorch
Like
object
attributes.
keeps like pointers back? That's a lot of memory. So if you're storing the loss, that keeps a pointer back to your whole graph. And so if you store the item, that's just a primitive object, which is a lot less in memory. Questions?
So the training, that code right there we have in also right now, that's gonna be calling all the functions that are part of part one, correct?
The what?
So there's like these functions, so there's like the train function right there, there's evaluate function.
So we're going to define that. We're going to define our
Alright.
model, and we're going to define, what was the other one? Evaluate.
And those are all part of part two.
Yeah, this is where you're actually going to be writing code,
Okay.
your own code. Okay, does that make sense about train? And you call backwards here. I guess you have to set up your gradient and loss function here. What does that mean? That means, well, we already have our gradient up here, right?
Yeah, I thought you already had defined it there.
Yeah, so you just have to like either declare those globally or passive it. So. Okay, evaluate. This is where your model is going to build the actual sentences. Does that make sense? So, prime string, that is what are we gonna run through the model to get our hidden state. Does that make sense? I think if I was doing Book of Mormon, you could set this as a sentence like, and it came to pass. I would just start it with that or something, or and then it can just like write sentences. You could make this dynamic so it changes every time you build a new sentence. But we're just have it, the default parameter is A, okay? So you're going to initialize your hidden state or your hidden variable. That's just you're gonna do through running your, well, wait, let's make sure we get this straight. Why does that say initialize your hidden variable? Because what are we doing right here? So we're running through our primer string, and we're running it through the decoder, and we're getting our new hidden state, which we're gonna call right here. Oh, it's because you need a random hidden state for the prime string, right? Does that make sense?
So is that what we're just doing random initial?
Yeah, random initialize. Because even if you're running the prime string through, you do need some numbers to go into the network as the hidden state for that primer string. Does that make sense?
Say that again.
So we have a primer string. It's
Uh-huh.
going to run through the network. But to run it through the network, you need a hidden state as well. So you just like randomly initialize a primer, like a hidden state that you're going to use to run through your prime string. Question?
So if we assume like we got the same hidden state every time, I know it's gonna be random, but like let's say we have the same hidden state every time and our parameters will change, should we get the same output for that?
No. That's a good question. Because we're going to sample randomly from our multinomial distribution. Peter.
So essentially this evaluate function is kind of like the sampling of the network to see what does it get.
Yeah,
And
this is
training
kind of like, you could call this like the test, I guess, or this is just like using the model. Yeah.
Like what does the model think is going to get?
Prediction, yeah.
And then the training is just, we know what it should be getting, so we're going to tell it what it should be.
Exactly. Jeremy.
So you're passing the hidden variable into the actual model?
Yes. That's how he set it up. I forget his name, the other TA. I should know his name, that's really bad. But he passes in his hidden state right here.
I see.
Yeah. I think so this initialize hidden, is that initializing hidden parameters? Like, or parameters of the model? No, this is just to get the model going, initialize your hidden state, right? So that's what this is. And that's what you call right here. It's just like, give me a hidden state to start out with, just some randomly. So I guess you don't even need to decide that. He uses zeros. He doesn't even use random. He uses zeros. Okay. All right. So then we run our primer through the model. We get our new hidden state that we can start actually predicting with. Our input becomes our primer input without the, oh yeah, so prime string -1.
Why do we say prime string versus like, what is prime supposed to be?
So the primer, we're priming the network.
Oh, okay.
Like
Yeah.
prime for
So what is this doing? This is grabbing the last element. So our new input is just the last element of the prime string. So if it was an and, it would be a D, right? And then that becomes our new input, which we'll just call the model parentheses input hidden right here. Does that make sense? Everyone okay there? So you're just gonna, because if our primer strings and it came to pass, we'll run that through right here through our model, and then we need to start with our letters, our X. We need an X to run through our model. So it'd be an S. Just grab the last letter and then run that through your model. So you call RNN parentheses S comma hidden, because that'd be the hidden state from that last iteration of the for loop. Okay? Any questions on that?
What was the S in your example?
So, and it came to pass, those are the last letter of our primer string.
Okay.
Yeah.
Just pass an if.
Yeah.
What?
So you pass an if.
Yeah, input's just one letter.
So does a space count as its own character in this case?
Yes.
So is it possible that our last character would actually be a space?
Yes, you could set it up like that. You could set up your prime string to include a space. Yeah. So then you make sure that it starts off with its own word. Yeah. Okay, and then once we run that through, and we get, so we're getting this output vector. What's the dimension of that?
However long.
If we have 100 characters in our alphabet, then it should be 100, right? So 100 probabilities. We go and we sample from that. So this gives us this top I. I don't know why I call it top I. That is a value which indicates which character is our guess, because we're just randomly sampling from this multinomial distribution using probabilities. So that's an index. Should you just append those integers together?
No, you have to convert it back.
Yeah, so you need to convert that to a character, and then you can start appending that, and then this is pretty easy, but we have you so just append the prime string, and then just run append the prime string through this for loop, and then return the predicted, which would be your prime string basically. Does that make sense?
Where does it say that to your prime string? Doesn't say that.
It doesn't say that, but that's what you want to do, because you want it to start off here with what your prime string is. Because if it's in it came to pass, you want to have that as part of your output. All right. Other questions?
Okay, so what was predicted again? That's like a.
That's just your string.
Just,
So it's like your concatenation of your prime string and then your predicted letters that have been appended together.
okay.
So that would be the phrase.
That
we
would be the
spit out.
phrase that it's going to guess.
That it guesses.
Yep, that it-
In addition to whatever you primed it with.
Yep.
So top I is what we need to change into a character.
That's exactly right, man. Okay. And then you need to create your own GRU cell, which we're going to talk about, and then you're going to run it. So these are some examples of where it runs. Oh, and someone asked how long your predicted length is. Yeah, that's just the variable you set here, right? You pass in, you can say I want 100 characters.
Yeah.
So here's as it gets going, it gets better and better. This is Lord of the Rings. So it starts actually Hobbit. It's kind of like Hobbiton a little bit, but bear. It does it can get kind of good. Okay.
How long does it take to train? Ish.
Oh man, I don't know. To be honest, on Colab, I've not ran this on Colab,
So I'm.
but I ran this for half an hour, 45 minutes, I think, when I did this lab. So, yes.
I tried to download the text files and it says that they're not found.
The link is broken. So.
Oh, the link's broken? I'll go and fix that. You can find the Book of Alma online, I think, if you really need to, but I'll go fix that. All right, this is the next. I think once you get know what's happening, that's not going to be too hard. But this is probably going to be kind of tricky. So this is our model class, right? So we initialize these variables. So what we need to do is we need to initialize a set of parameters. We need to set up a GRU class, and then we need to run it through our GRU class, our input and our hidden. So if our input is an integer, let's just talk about this real quick. Can we just run our integer through the network? No, right? We need to convert that integer to a one hot, right? So if it's like an A, put that in its corresponding index, then we correct. But what should we output? What should we output here? A vector of 100 probabilities, right? So now let's talk about the GRU cell, because this is very important. This is what you'll be implementing.
So when you're talking about having an integer, is that integer going to be referencing the